the Rust programming language book, and we were on chapter 2. As mentioned earlier, readline puts whatever user enters into the string, we pass to it, but also returns a result value. Result is an enumeration, so yeah, a result will either give you an OK or an error value, which we have already discussed in last video, often called an enum, which is a type of, can be one of the multiple possible state. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of this result type is to encode error handling information. Results variants are OK and error. The OK variant indicates operation was successful, and inside OK is the successfully generated value. The error variant means the operation failed, and error contains information about how or why the operation failed. Okay, so I think here, if you remember, inside the OK value we were getting a U8, right? So instead of that, if we could have got the actual value which is present in guess, that would have been much more better, I guess. But I'm not sure why they decided to go ahead with that. Value of the result type, like values of any type, have methods defined on them. An instance of the result has an expect method that you can call. If the instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of result is an OK value, expect will take the return value that OK is holding and return that value to you, so you can just use it. In this case, the value is the number of bytes in the user input. So I guess in OK we were getting the number of bytes in the user input, which is U8. If you don't call expect, the program will compile, but you will get a warning. Rust once that you haven't used the result value returned from the read line, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, but in our case we just want to crash this program when a problem occurs, so we can use expect. So you will learn more about recovering from errors in chapter 9. Printing values with println and placeholders. Aside from closing curly bracket, there is one more line to discuss in the code so far. The line println prints the string that now contains the user input. The curly braces set of curly brackets is a placeholder. Think of a curly braces little crab pincers that hold a value in place when printing the value of a variable. The variable name can go inside the curly braces. When printing the result of evaluating an expression, place empty curly brackets in the format string and follow the format string with a comma separated list of expression to print in each curly bracket placeholder in the same order. Printing a variable and result of an expression in one call to println would look like this. This code would print x equal to 5 and y equal to 12. Testing the first part. Let's test the first part. Run it using cargo go. Okay, at this point, the first part of the game, we are getting input from the keyboard and then printing it. Next, we want to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We will use a random number between 1 and 100, so the game isn't too difficult. Rust doesn't yet include random number functionality. However, the Rust team does provide a rand crate with said functionality. Using crate to get more functionality. Remember that a crate is a collection of Rust source code. Why is the project we have been building is a binary crate which is an executable. The rand crate is so what basically they are trying to say here is that we will include a rand dependency called rand, and it will help us to generate a random number. Okay, if you have worked with Java, just like we add a node modules to our package JSON, it is the same thing here, which we will add to our cargo.toml file, which contains code that is intended to be used in other program and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses RAND, we need to modify the cargo.toml file to include the RAND crate as a dependency. Open that file now and add the following line to the bottom beneath the dependency section header that cargo created for you. Be sure to specify RAND exactly as we have here with this version number, or the code samples in this tutorial may not work. File name cargo.toml, okay, RAND 0.8.5. okay, so I will add this dependency, the cargo.toml file. Clicking on save, you can automatically see that the Rust analyzer, and it automatically fetches the dependency for us. So I will go again back to main.rs. Everything that follows a header is a part of that section that continues until another section starts. In dependencies, you tell cargo which external crates your project depends on and which version of those crates you require. In this case, we specify the RAND crate within the semantic version specifier. Cargo understands semantic versioning, sometimes called SEMVer, which is a standard way of writing version numbers. The specifier to shorthand, which means any version that is at least but below 0.9.0. Cargo consider this version to have public APIs compatible with version. Ensure that you will get the latest batch. Any versions regret is not guaranteed to have the same API as what the following example uses. Okay, you may see different version number, but they will be compatible with the code thanks to SEMVer, and different lines depending on the operating system, and the lines may be in different order. When we include an external dependency, cargo fetches latest version of everything that the dependency need from the registry, which is copy of data from credit.io. Credit.io is people in the Rust ecosystem push their own open source Rust project for others to use. After updating the registry, cargo checks the dependency section and download any crates listed that aren't already downloaded. In this case, although we have only listed RAND as a dependency, cargo also grabbed other crates that RAND depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependency available. If you immediately run cargo build again without making, you won't get any output aside from the finish line. Okay, cargo is already downloaded and compiled dependency, and you haven't changed anything about them in cargo.toml file. Okay, like that ensure you can rebuild the same every artifact every time, or anyone else builds your code. Cargo will only use version of the dependency you specified until you indicate otherwise. For example, say the next version of the RAND crate comes out and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.log file the first time you run cargo build. So we may now have this in the guessing game directory. Okay, updating a crate to grade. When you want to update a crate, cargo provides the command update, which will ignore the cargo.log file and figure out all the latest version that fit your specification. Cargo will then write those versions to the cargo.log file. Otherwise, by default, you only look for version n less than. Okay, if RAND crate has released 2 versions, you would see the following in your cargo update. Cargo ignores. Okay, at this point you would also notice a change. Here you would have to update to look like this instead. Okay, so if they are saying that if we are using 0.8.4 and suppose there are 2 versions available, 0.8.5 and 0.9.0, then using cargo update will only update it to 0.8.5. But if you want to update to 0.9.0, you have to do it manually. The next time you run cargo build okay, let's go to crates.io and check what is the latest version of RAND package. It is 0.8.5. okay, Okay, generating a random number. Let's start using Rust. Trying to generate a number to guess. The next step is to update src underscore main.rs as shown in listing 2-3. Okay, so we will update our code to look something like this. So this is a println, then we are generating a random number using the rand package. I don't know why it is not giving me an error. I think it is still downloading the dependency. This could have to do with my internet connection. Let me close VS Code and try again. I think there is an issue with my network, that's why it is not able to download the required dependency. But what basically it is doing is that it is using the rand package to generate a random number, I think from 1 to 100. Then we are printing that random number, asking the user for his input, reading the input, okay, and just printing out whatever the user has guessed. First, okay, the defines methods at random number generator implement and add this trait must be in scope. A trait is just like an interface in Java. Next we are adding two lines in the middle. The first line gives as the particular random number we are going to use one that is local thread of execution and is distributed by the operating system. Then we call genRange method on the random number generator. This method is defined by the RNG trait that we brought into the scope with the use rand : RNG statement. Okay, gen underscore range method takes a range expression as an argument and generates a random number in the range. The kind of range expression we are using here takes the form start : equal to and is inclusive in the lower and upper bounds. So we need to specify 1 : equal to 100 to request a number between 1 and 100. You won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation. Okay, it is referring to just use the documentation for rand. The second new line prints the secret number. Yeah, okay, this is useful when you are developing the program to be able to test it, but we'll be deleting from the final version. Okay, otherwise it won't be much of a game if we know the random number previous like already know the random number before providing an input, then it won't be much of a game. Now comparing the guess to the secret number. Okay, so I think there is a compare. So instead of using equal, double equal to or triple equal to in JavaScript, I think Rust has a compare thing which allows us to compare. Now that we have as we will explain. Okay, let's just copy paste this code. Okay, we have included the dependency. Yeah. sure why this error is coming. Let me go back to the previous code. Okay, this is something like user and colon RNG. Okay, now why is this complaining? Expected reference. Okay, the secret number is in string, but we need it in expected reference string, found reference integer. Okay, so this is I32 and we want to convert it into an integer. I'm not sure if we, I don't think borrowing applies for I32 or integer or float or double values. I think it only applies for string, struct, enums, those kind of data types. First we add the line use rand colon range. The RNG train defines method that random number generator implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Next we are adding two lines in the middle. In the first line we call rand colon thread underscore range function. Okay, I think we already did that. Okay, so first we add another use statement bringing the type called std cmp ordering into scope from the standard. The ordering type is another enum and has the variants less, greater and equal. These are the three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom that uses the ordering type. The cmp method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess to secret number. Then it returns a variant of the ordering enum we bought into scope with the use statement. Okay, we are using the match statement because we want to get either of these three values. I think we can use I don't think we can use if statement, I guess. Let's see. So if I use if guess dot cmp number. Okay, so yeah, I think we can do something like this. Then use an else if guess.cmp, but I think match looks better in this case. Match expression is made up of arms, and arm consists of a pattern to match against and the code that should run if the value given to match fits the arms pattern. Takes the values given to match and looks through each arms pattern in turn. Patterns and match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure to handle them. All these features will be covered in detail in chapter 6 and chapter 18 respectively. Let's walk through an example with the match expression. We use here say that the user has guessed 50 and the randomly generated secret number this time is 38. When the code compares 50 to 38, the cmp method will return greater than because 50 is greater than 38. Okay, match expression gets the ordering greater value and starts checking the arms pattern. It looks at the first arms pattern. Okay, yeah, this is pretty self-explanatory. The core of the error states that there are mismatch type. Okay, Rust has a strong static types. However, it also has a type inference. When we write Rust was able to infer the guess should be a string and didn't want us to write the type. Secret number on the other end is a number type. A few can have a value. Okay, 60 as well as Rust defaults to I32, which is type of secret number. Okay, ultimately we want to convert the string the program reads as an input into a real number, so we can compare it numerically to the secret number. We do so by adding this line to the main function body. Okay, so we are converting this to an U32. Yeah, which makes sense because you can compare to integer or float values, right? You cannot compare to string values. Like, you can, but it doesn't really make sense to compare two values, two string values, whether they are greater than or less than. Okay, so basically what they have done is that after reading the guess, they have defined another guess variable. Okay, so Rush do allow us to do that. This is, I think, called shadowing, but I typically want to stay away from it. But yeah, you can do that, like guess dot trim will remove the any space at the leading or at the trailing. And again, okay, expect, because if we enter something other than a number, then the conversion might fail. Please type a number. Okay, and what type annotation needed? Does it allow for I32? Yeah, it does. Unsigned 32. Like, I will go for I32 because it will include both signed and unsigned. Okay, now that error is gone as well. Okay, we create a variable name guess, but wait, doesn't the program already have a variable name guess? It does, but hopefully Rust allow us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess str and guess. For example, we will cover this in more detail in chapter 3, but for now know that this feature is often used when you want to convert a value from one type to another type. Okay, so use shadowing when you want to convert a value from one type to another type. Okay, shadowing when you want to convert value from one data type to other data type. We bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess variable that contained the input as a string. The trim method on the string instance will eliminate any white space at the beginning and at the end, which we must do be able to compare to the string to U32, which can only contain numeric data. The user must press enter to satisfy a read line and input the guess. Okay, yeah, guess looks like we also get the slash, and the slash and represents to a new line on Windows. Enter results in a carry is written and a new line. The trim method eliminates. Okay, so the trim method eliminates slash n or slash r slash n. Okay, the parse method on string converts a string to another type. However, we use it to convert from string to a number. We need to tell Rust the exact number type we want by using, yeah, we are explicitly specifying the data type. The colon after guess tells Rust we will annotate the variables type. Rust has a few built-in number types. The U32 seen here is an unsigned 32-bit integer. It is a good default choice for a small positive number. You will learn more about other number types in chapter 3. Additionally, U32 annotation in this example program and comparison means that Rust will infer that secret number should be U32 as well. So now the comparison will be between two values. The parse method will only work on characters that can logically be converted into numbers and so can easily cause error. If for example the string contains something like this, there would be no way to convert that into an error and that might fail. We will treat this result the same way by using expect method again. Okay, parse returns an error, couldn't create a string, the expect call will crash. Parse can successfully convert the string to a number, it will return the OK variant of result and expect will return the number that we want from the OK value. Nice, even though spaces were added before the guess, the program was still able to figure out the guess. Run the program to verify. Yeah, you can try running the program. So yeah, that's it for today's video. In the next video we will start with this allowing multiple guesses with looping. Thank you for watching. See you in the next one.